For this example, we'll identify the conic section and then graph the polar equation. We have r is equal to 2 over 1 minus cosine of theta. The first step in identifying the conic section is to write it in standard form. And standard form is equal to r equals EP over 1 minus E times the cosine of theta. It's important in standard form that this constant be a 1. And since we have it a 1 already, we do have it in standard form. So now we can see that our E is the number in front of cosine of theta. So in this case, our E is equal to 1. We can also see that EP is the constant in the numerator. So EP in this case is equal to 2. So therefore, if we substitute 1 in for E, we'll get 1 times P is equal to 2, or simply that P is equal to 2. So we have E equal to 1 and P equal to 2. In step 2, we can identify the conic section based on E alone. Since E is equal to 1, that automatically means that our conic section is a parabola. Remember, if E is less than 1, we have an ellipse, and if E is greater than 1, we have a hyperbola. But in this case, we have a parabola. In step 3, we want to determine symmetry. In this case, notice that we have cosine theta in our equation. When we have cosine theta, this means we have symmetry with respect to the polar axis. That's going to help us in our graph. If we had sine theta, we would have symmetry with respect to the line theta equals pi over 2. But in this case, our curve will be symmetric with respect to the polar axis. Now we're ready to start graphing. Based on the standard form, we know that our focus is located at the pole, and because P is equal to 2, we have our directrix located at the line x equals -2. We know that our vertex is halfway in between these two. We also know, based on the standard form of EP over 1 minus E cosine theta, when this represents a parabola, we know that our parabola will open to the right. If this had been 1 plus cosine theta, our parabola would have opened to the left. So we have the vertex now. This vertex right here is located at the r theta point of 1, pi. The radius is 1 and the angle is pi. Now let's come up with a couple more points to graph our parabola. If we let theta equal pi over 2, then we'll have an r value which will equal 2 over 1 minus the cosine of pi over 2. Since the cosine of pi over 2 is equal to 0, we have r equals 2 over 1 minus 0, which is just 2. So in other words, we have another point that we can plot, which is when r equals 2, theta equals pi over 2. So that would be the point 2 pi over 2 right here. Because we have symmetry with respect to the polar axis, then we'll also have a point down here at 2 when the angle is 3 pi over 2. Now we can sketch a graph of this conic section. And I'll label these 2 points to complete the graph. This angle is pi over 2, the radius of 2, so that's the point 2 pi over 2. And this point down here is 2, 3 pi over 2.